Hi, I'm Maha, and will be presenting for you multi-value alignment in normative multi-agent system using an evolutionary optimization approach. So first, normative multi-agent systems are used for modeling complex systems that has autonomous agents with different objectives to achieve, and that uses norms to coordinate this behavior. So norms are social norms spread across a group of agents to regulate their behavior. For example, in a traffic system, we know that in most countries, it's the norm to give priority to emergency vehicles in a traffic scenario, or the norm for senior citizens to sit in the front seats. However, as important as these norms is to consider the values of these agents as well. So by values, we mean motivational values, which represent standards that serve desirable objectives, such as equality, fairness, so on. So here we come across a challenge of value alignment in normas or normative multi-agent systems. So how to ensure that we apply the norms that that are aligned with the values as well. So researchers have tried their best to investigate value alignment in normas. However, their work has one of the following challenges. So first they might try to match these norms with only one value or with a preferred subset of values. However, in real applications, we would like to match all the norms with all the values. And also to consider if it's a heterogeneous multi-agent systems, and what if these values are different or incompatible and so on. And third is some researchers try to drive directly the norms from the values set. However, they might not be linked or might not be directly linked. So we need a solution that can choose the best set of norms, considering heterogeneous groups, of course, and we try to align multiple values that can be compatible or incompatible and from heterogeneous groups of agents, and align the norms and values and consider them as independent sets. So for proposing a solution, we followed the following methodology. First, we used the parametric norms, which define each norm as a set of parameters. This gives us the flexibility that different norms can be assigned to heterogeneous groups of agents. Second, we formulated this problem as a multi-objective optimization problem, where we used the values or defined the values as the objectives to be optimized and the norms as the decision variables. We solved this problem using multi-objective evolutionary algorithm using 4 different types: NSGA2, MOEADD, SPEA2, MOMBI2. And we use multi-objective evolutionary algorithm because they have proven their efficiency to handle different problems in different domains before. However, the problem is that the multi-objective evolutionary algorithms optimization process produce a set of non-dominant solutions, or the Pareto front set. So we need to have a reasoner that can reason this Pareto front set and produce one final solution. So we propose NOVA, Norms Optimization and Value Alignment Model, which has 2 main types of agent: regulative agent or central unit, and regular agent. So the regulative agents first collect the values, its own values and the values of the regular agents, and send them to the optimizer. And then it sends a norm subset with an initially random values assigned to it, because the end aim is to find out the best set of values for these norms. And then the optimizer uses the values as objectives to be optimized and the norms as the decision variables, and produce per set of Pareto front solutions. Then the main reasoner will use this set and send the optimum objectives with their corresponding norms values to the regular agent to carry out a decentralized reasoning process for selecting the final solution. So to evaluate this model, we apply the tax system scenario. We can see that here we have two main type of agents. First, the government and the citizens. The citizens have the normal agents and evader agents. So evader agents are the agents who decide not to pay taxes, and they can be caught or not caught after they do not pay the taxes. And if they are caught, they would pay fines. So the fines are collected from evaders. And these fines, in addition to the collected taxes, and in addition to an invested rate multiplied with this amount, are redistributed again to the citizens. Okay, so this scenario, we run it for 500 generation in the optimization process for 30 execution, and we handle two main scenarios with 2 objectives and 5 objectives. So, or 2 values and 5 values, which we will explain shortly. So first, what are the norms? The first norm is the collect, which represents the collection rate to be collected from every group of citizens. So there are 5 groups of citizens. Group number 1 is the poorest, and group number 5 is the wealthiest. And redistribution is the redistribute rate to every group after collecting the money, fines, and calculating the interest rate, and then redistributing them. And then 3 is the catch. This is the catch rate of evaders. And 4 is the fine, is how much these evaders would pay if they are caught. And the values or objectives are as follows. So for the value of the government is equality. It's based on or calculated based on the Gini index, which try to make each of the citizens or the agents have common wealth. So W is for the wealth. And then the second value is for the middle class group, group number 3. And they are trying to reach fairness. And here, fairness is defined as trying to push down the evaders who didn't pay taxes to group number 1, so that they reach the poorest group. For objective number 3, it is the value of group number 5, which is the wealthiest group. They are trying to keep their wealth, so they are trying to keep the highest ratio for their wealth compared to the other group. And the value of group number 4 is to maximize their gained amount from the redistributed amount. So CR is the redistribution amount, which is calculated by taxes plus fine time interest rate. And for objective number 5, it's the value of group number 1, the poorest, and it tries to minimize the amount of taxes calculated or collected from them. So first, evaluating the produced or the performance of the different multi-objective evolutionary algorithm, we can see here that in case of true objective scenario, which is only using the equality and fairness objective, however, the objective scenario uses the 5 values. So for the two objective scenario, you can find that MOMBI2 has the lowest performance. However, NSGA2 has a more stable performance somehow. But in the 5 objectives, NSGA2 come out to be has the lowest performance. So from these two figures, we can say that the algorithms that produced reasonable results in both scenarios is MOEADD, which is somehow reasonable in both scenarios. And this is also seen from the Pareto front set solutions. We can see here how the MOEADD is stable and produce optimum solutions for both objectives. And here also the red dots represent the performance of the MOEADD, which is reasonably good as well. So after the optimization process, the decentralized reasoner act, and what happens is that the citizens start voting for the preferred objective or solutions. And here we can see when we compared our work with the state-of-the-art work that also tried to do value alignment using genetic or simple genetic algorithm, it was capable of reaching or optimizing the equality value and getting 0.95 and 0.93. However, our model is able to do like multi-objective optimization or multi-value alignment simultaneously. So we were able to optimize both values in parallel and still have close results to the state-of-the-art work. So in conclusion, we propose a NOVA, Norms Optimization and Value Alignment model that represents the multi-value promotion model. It uses multi-objective evolutionary algorithms and is able to produce a set of norms that is aligned with multiple values of heterogeneous group that are optimized, and finally produce a final single optimum solution using a decentralized reasoner. Thank you.